Hey everyone, let's do achieve section 3.4, number 10. In this problem, we're asked, what is the velocity of a ball dropped from a height of 20 meters when it hits the ground? So this ball is just dropped at a height of 20 meters from rest, and it falls down and it hits the ground. What's the speed on impact with the ground? Give your answer to 3 decimal places and use g equal to 9.8 meters per second squared. So what's all this about? Well, this is the formula that they want you to use. It's in the textbook in section 3.4. They kind of explain where it comes from, but this is the height S of this object, the ball in this case, or any object that is under free fall motion. In other words, the only force acting on it is the acceleration, the force from the acceleration due to gravity. And this G is indeed the gravity, acceleration due to gravity rather. In this case, they want you to use 9.8 meters per second squared. If we're doing the English system, it would be 32 feet per second squared would be the corresponding value. So if you plug in G equals 9.8 here, you'll have negative 4.9 t squared. V sub 0, what's the initial velocity? Well, since it's dropped from rest, the initial velocity is just 0. That whole term goes to 0. Okay, and then S sub 0, that's the initial height. And since we're 20 meters, S sub 0 is 20. Okay, so this is the height of this ball above ground. And now we want to know, when does it first of all hit the ground? Well, when is the height equal to 0? Well, right, that's when the ball's on the ground. So I just set this equal to 0. So if this statement is true, then 4.9 t squared is 20. Dividing by 4.9, I get this, and then I can take the square root to solve for the time. I only need the positive root because time starts at 0 and then goes forward, so there's no negative time here. And this is the time that it takes, about just over 2 seconds. But then the question is, of course, what's the velocity? So how are we going to find the velocity? Well, so far no calculus. Now we have calculus. Calculus is find the derivative of the position function, because that's the velocity. Velocity is the rate of change of your height with respect to time. And it's a pretty easy derivative to take. What's the velocity going to be? It's just negative 4.9, derivative t squared is 2t. So negative 4.9 times 2 is negative 9.8 t. Of course, the derivative of 20, a constant, is 0. So that's it. That's the velocity, which kind of makes sense if you think about it, because the only force acting on it is the acceleration due to gravity, which is negative 9.8 meters per second squared. So all I need to do is take this time, multiply it by negative 9.8, and that will give me my velocity on impact. Now, they wanted you to round to 3 decimal places. It's very important to pay attention to that. So be real careful when you do this. Don't round off any intermediate results. So let me show you how to do that here. In the calculator, when I take the square root of 20 divided by 4.9, so I get, of course, this, and I rounded this off here, but in order to be, minimal rounding error, let's just take this value, which is stored in the calculator, as answer, and let's multiply answer by negative 9.8 to get the actual velocity on impact. The answer button is right down here above the little negative sign, so I can just do negative, the little negative sign, right, for negative. I'm using that, not the subtraction sign, so be careful there. Negative 9.8 times answer, right? So there will give me my velocity. And so be careful again about rounding. It's negative 19.799, because that 9 there rounds the 8 up. Okay. So hope this makes sense. Of course, oh, one other thing, why is the velocity negative? What's that mean? The negative velocity means it's traveling downward. So on impact, the actual speed is, of course, 19.799 meters per second squared, or sorry, meters per second, not squared. That's the speed, but the negative sign of velocity indicates sort of the direction that's going downward on impact, of course. Okay, hope this makes sense.